So this video is going to be just a quick review of the entire reactions unit. There we go. First thing we need to talk about is during any reaction, law of conservation of mass. So all the mass is the same. Nothing is matter can't be created or destroyed. It just gets changed into different forms. So here's an example of chemical reaction. If you look, there's one carbon on the left. There's one carbon on the right. So these are called the reactants. These are called the products. So there are 4 hydrogens on the reactant side. There's 4 hydrogens on the product side. There's 1, 2, 3, 4 oxygens on the reactant side, 4 oxygens on the product side. So they changed into different substances. So we've got methane and oxygen, and it changed into carbon dioxide and water. So it changed forms, but the atoms are still there. So that's conservation of mass. Physical properties. Those are properties that can be observed without changing the identity of the substance. So it stays the same stuff. Examples of these are color, density, hardness. Malleability is the ability to be molded and shaped. Metal is malleable. Play-Doh is even more malleable because it's squishy. Solubility, that's how it can dissolve into water. Boiling point is the temperature at which it boils. Melting point is when it melts. Texture, how it feels. So those are all physical properties. Physical changes are when we change one of those properties. And so some examples of that would be ice melting. So it's still H2O. It's still water the whole time. It just goes from solid water to liquid water. So it changes, but it's still water the whole time. Still H2O. Splitting a piece of wood, it's still wood. It's not a different substance. It's just a smaller piece. Ripping paper, same thing. It's still paper. It's just ripped. Here's metal that was bent. So metal is malleable, and so it's bent. So that's physical changes. Chemical properties, characteristics that can be observed during a chemical change. So that'd be like flammability, so it can catch on fire, reactivity, acidity, oxidation, so how quick it will oxidize. For iron, that's called rusting. So chemical changes is when a new substance is formed. So you have one substance and it changes to a new substance. So trees being on fire. So trees are flammable. When they actually burn, they change from wood to ash. So that's a whole different substance. So that's a chemical change. Iron oxidizes, so the iron reacts with oxygen and it creates rust, which is iron oxide. So it went from iron to iron oxide. So that's a whole different substance. Fireworks are an example of chemical change. Here's baking soda and vinegar. So that's chemical change. You have vinegar, which is an acid, and then you have baking soda, which is a base. You add them together and they make salt water, basically. So evidence that a chemical change has occurred, we have a couple of them. This isn't all of them, but it's the ones we tend to look for. So you have it produces light, maybe it changes temperature. It produces gas, so it could be bubbles. Not everything makes a bubble. So it could produce gas. Unexpected color change. It says changer, so just say change. Unexpected color change. So like if I was going to take blue water and red water and mix them together and I got purple, that would be physical change. But if I took blue water and red water and mixed them together and got orange, you'd be like, well, that's not what I was expecting. So that could be a chemical change. Change in odor could be evidence of a chemical change, or if it produces a loud sound, like shooting a gun or something like that. And so just because it does one of these doesn't mean it's a chemical change, but it's pretty good evidence that a chemical change may have occurred. Properties versus changes. Properties are what could possibly change, and then a change is when it actually happens. So physical property of like metal is malleability. So if it's malleable, the metal could bend. So the property is it could happen. And then when you actually bent the metal, so when it's bent, that's the change. So property, the metal could bend, change, it is it did. Chemical example, flammability. The paper could catch on fire, so that's a property. It's flammable. And then the change is when we actually light the paper on fire. Chemical formulas. So these are just formulas that show the atoms that are in different compounds or molecules. So like salt is sodium and chlorine together. Sucrose is carbon, hydrogen, and oxygen. And remember, these little subscripts tell you how many of each element. So there's 12 carbon atoms, there's 22 hydrogen atoms, and 11 oxygen atoms. Okay, but like up here, there's only one sodium atom and one chlorine. So that's why we didn't put the number, is because it's just one. So to count atoms, so here's a molecule of water. It has 3 atoms total. So it has 2 hydrogens, and then it has 1 oxygen. And then if we look, it has only 2 elements, though. It only has hydrogen and oxygen for elements, but it has 3 atoms because it has 2 hydrogens. Now, formulas can have coefficients too, just like in math. And so this means that we have 3 carbon dioxides. Okay, so what that looks like, we have 3 carbon dioxide molecules, but you don't always have the picture. Sometimes you just have the formula. And so what we're going to do is we're going to distribute this. So this carbon is really, there's just 1 carbon there. So I went ahead and put a 1 in. Usually we don't do that. And now, just like math, we're going to use the distributive property for that 3. So we take the 3, multiply it by the 1 carbon, and then take the 3 and multiply it by the 2 oxygens. So that gives us 3 carbons, so 3 times 1. Okay, so that's 3 carbons, and then 3 times we have 2 oxygens. So that's 6 oxygens total. And we can look at our picture over here. So 3 carbon dioxides, there's 1, 2, 3 carbons, and 1, 2, 3, 4, 5, 6 oxygens. So that's how you coefficients work in chemical formulas. So molecules are when 2 or more atoms are bonded together. Here's some examples of them. 2 different kinds of models. You have the ball and stick. So the spheres are the atoms, and then the sticks are the bonds. It's like right here, this is a double bond because there's 2 sticks. Okay, and then over here, we just have the spheres. And so where they touch is where the bonds are. So like this water molecule up here has 2 bonds. And this one has a whole bunch of bonds. And so they don't have the sticks. It's just where the spheres touch each other. That is where the bonds are. So those are molecules. Extended structures are bigger structures. It's a repeating pattern of the atoms and how they're bonded together. And they can always they can add on more to make bigger structures. So extended structures are usually bigger. This is a salt, grain of salt. This is graphite. And so this is in sheets. This is what's in your pencil. So when you rub it on your paper, those sheets come off, and that's what leaves that gray line behind. You're actually leaving behind layers of graphite. So those are extended structures. They tend to be a lot bigger, form crystals. Pure substances versus mixtures. So this one's a review. Pure substance is all the same molecules or atoms. And then mixtures are when you have a mix of molecules or atoms. And so like over here in the purple square, this is pure water. And then in the orange square, this is water with carbon dioxide. So maybe it's like sparkling water or carbonated water. And so it's got water and carbon dioxide in it. So mixture, things mixed together. Pure, just one type. And that's the end.